Introducing the 7 chapters. Welcome. Before we touch a single file on your machine, I want to give you the full picture of where we are going and why the order we build things matters as much as the things themselves. Here is the honest truth about most developers using AI coding tools. They are getting maybe 20% of what is possible, not because the tools are weak, because they are using them in the most basic way available. Open a chat window, paste some code, get an answer, close the tab. Tomorrow they open it again, re-explain the same context they explained yesterday, and repeat. The AI has no memory. Every session starts blank. Every session ends the moment you close the window. This creates a specific kind of friction, not the obvious friction of a tool that does not work. That would be easy to abandon. This is the subtle friction of a tool that works just well enough that you keep using it, but not well enough that it transforms how you work. You still hold all the context in your head. You still re-explain your stack every time. You still correct Claude when it uses a pattern that does not match your project's conventions. Claude Code, configured the way we configure it today, fixes all of that. There are 7 chapters. I will introduce all 7 right now. Each one will make more sense because you heard the others first. The foundation. Windows Terminal, Node.js, NPM, and Claude Code itself installed on your machine. Your Anthropic API key connected. This chapter takes 15 minutes and you never revisit it unless you get a new machine. Nothing else in this course runs without it. This is the single most important chapter in the course. Claude has no persistent memory between sessions. Claude MD is a markdown file that Claude reads automatically at the start of every session. Whatever you write in it becomes part of Claude's working understanding for that entire session. Write it once. Claude reads it every time. There are 3 layers: a global file for your personal preferences across all projects, a project file per repo, and subfolder files that activate only when Claude is working in that specific area of the codebase, ideal for modules with special security rules or unusual constraints. This chapter comes second because every other chapter builds on it. Skills read it, hooks enforce it, subagents inherit it. MCP results get interpreted through it. A strong CLAUD.MD amplifies every other feature. A weak one limits them all. Out of the box, Claude Code can only see local files and run terminal commands. MCP, Model Context Protocol, is the open standard that connects Claude to the outside world. Think of each MCP server as a plugin that gives Claude a new capability. The GitHub server lets Claude read your repositories. The Postgres server lets Claude query your database directly. The Perplexity server gives Claude live web search. Over 400 servers exist today. Each one takes about 5 minutes to install. You add a block to a settings.json file and Claude Code connects to it at startup. A hook is a script that Claude Code runs automatically at specific moments in its operation cycle, before a tool is called, after a file is written, when a session ends. Claude does not decide whether to run it. Claude Code runs it for every matching action, every time. If the script says block, Claude is blocked. No argument, no override. We build 3, one that auto-lints every file Claude writes, one that blocks dangerous terminal commands before they execute, and one that sends a Windows desktop notification when Claude finishes a long task. Every developer who uses AI tools seriously discovers the same problem. 5 or 6 types of requests produce much better results with a specific setup prompt, and so they either paste that setup prompt every time, or they accept worse output without it. Skills eliminate this entirely. A skill is a markdown file defining a complete workflow. You write it once and invoke it with a / command. Claude reads and follows it exactly every time with no forgetting. Each skill also has a description field that Claude reads to auto-activate the skill when your request matches, even without the / command. We build 3, a systematic code review, a hypothesis-driven debug protocol, and a safe git commit helper. Every AI model has a context window limit. On long complex tasks, it fills up and quality drops. A subagent is a completely separate Claude worker with its own isolated context window, its own system prompt, and its own tool permissions. The main agent orchestrates them. Multiple subagents run simultaneously. A database subagent thinking only about SQL and schema will write better migrations than a generalist also thinking about React and tests. Isolation produces specialist quality output. We build 3 subagents, a database expert, a test writer, and a security auditor with read-only access by design. This is the culmination. Agent teams let you compose multiple specialists dynamically from a single prompt. Where subagents are standing team members with job descriptions, agent teams are task forces assembled on demand. You describe what you need, who should do what, and whether things run in parallel or sequence. The lead agent handles the orchestration. For teams you use regularly, you save the composition in a teams.json file and reference them by name. A full feature, schema, API, tests, security review, completed in one session. Chapter 1. Installation. Getting Claude Code running on Windows. This chapter is purely setup. There is no configuration here, no clever architecture, nothing interesting conceptually. It is just the groundwork. But it has to be solid because everything else sits on top of it. We need 4 things. Windows Terminal, a modern terminal that handles Claude Code's output cleanly without breaking. Node.js, the JavaScript runtime that Claude Code is built on, version 18 or higher. NPM, the Node package manager that comes bundled with Node.js, how we install Claude Code. And your Anthropic API key, the credential that authenticates your installation with Anthropic's servers so the AI model can respond. One note on cost. Claude Code uses Anthropic's API, which means you pay for usage. For regular development work, most developers spend $5 to $20 a month. Intensive agentic sessions with multiple subagents cost more. You can set a monthly spending cap in the Anthropic console to avoid surprises. Do that after step 6. Steps key. Press the Windows key on your keyboard. That is the key with the Windows logo on it, usually between Control and Alt at the bottom left. A search bar appears. Type the words Windows Terminal. Results appear. Look for the one labeled Windows Terminal and click on it. A dark window opens with the command prompt. This is your terminal for the entire course. If Windows Terminal does not appear, open the Microsoft Store instead. Search for Windows Terminal, install it for free, then come back here. Click inside the terminal window. Type Node. Press Enter. If you see a version number like v20.111.0 and the number after the V is 18 or higher, skip to step 4. Node.js is already installed. Press the Windows key. Type Edge. Open Microsoft Edge. In the address bar type nodejs.org and press Enter. You will see 2 green buttons. Click the one that says LTS. A file downloads. When it finishes, click it. The installer opens. Click Next. Accept the license, click Next. Leave the destination folder at the default. Click Next. On the custom setup screen, click Next. When you see Automatically install the necessary tools, check that box. Click Next. Click Install. A Windows permission pop-up appears. Click Yes. Wait 2 to 3 minutes. Click Finish. Now close Windows Terminal completely by clicking the X. Press the Windows key. Type Windows Terminal, reopen it. You must restart it for it to see the new Node installation. Type Node V and press Enter. You should now see a version number. Also type npm tv and press Enter. You should see npm's version 2. Both are now installed. In Windows Terminal, type this command exactly: npm install ganthropic ia Claude Code. That is npm space install space. Then Piaparisi, the Athrop A Cade code, all one word, all lowercase, with an @ symbol at the start and a / in the middle. Press Enter. Lines of output scroll by as npm downloads and installs. This takes 1 to 2 minutes. Wait until the prompt returns. Type Claude, version, and press Enter. You should see a version number like 1.x.x. If you do, Claude Code is installed. Open Edge. In the address bar, type console.anthropic.com and press Enter. Log in or create a free account. Once on the dashboard, look at the left sidebar for the item that says API Keys. Click it. Click Create Key. In the name field, type My Claude Code. Click Create Key. A long string appears starting with skant, followed by letters and numbers. This is your API key. It is shown exactly once. Click the copy icon next to it. Press the Windows key, type Notepad, open it. Press Ctrl and V to paste your key. Press Ctrl and S, name the file, apkey.txt, save it to your desktop. Important, your API key is a password. Do not paste it into a chat message, a GitHub commit, or a screenshot. Anyone with it can make API calls charged to your account. While you are here, set a spending cap. Look in the left sidebar for billing or usage limits. Set a monthly limit you are comfortable with. Go back to Windows Terminal. Type Claude config set Anthropic API KEAQUI, then press spacebar once. Then right-click in the terminal window to paste your key. The full line looks like Claude config set Anthropic API KAKPAs Ant your key here. Press Enter. You will see a brief confirmation. Type cd prefile profile prefile % and press Enter. That takes you to your home directory, something like C, user's your name. Type McDear projects and press Enter. Type cd projects and press Enter. Type mkitdir my Claude project and press Enter. Type cd my Claude project and press Enter. Claude Code starts. You will see a welcome screen and a prompt that looks different from the regular terminal. If it asks you to confirm any initial settings, press Enter to accept the defaults. Once the prompt is ready, type Hello. Which folder are you running in? Press Enter. Claude responds, probably telling you the folder path. This confirms it is running and the API connection is working. Now delete the apkey.txt file from your desktop. Press the Windows key, type File Explorer, open it, navigate to your desktop, right-click apkey.txt, and click Delete. This chapter is the ground under everything else. You cannot see it once the other layers are built, but remove it and nothing works. Node.js and the Claude Code binary are the engine. The API key is the ignition. Every other chapter adds configuration on top of this running engine. The things you installed here are rarely touched again, only when updating or changing machines. 1. Code base orientation. Navigate to any existing project folder. Launch Claude, then ask, summarize what this project does, its architecture, and the main entry points. Claude reads every file and produces an accurate overview. This alone saves hours when joining an unfamiliar codebase. 2. One-shot function generation. Describe a function in plain English. Claude writes it with error handling into the right file. Without calludi.md, it may not follow your exact conventions, but the raw capability is there from session 1. 3. Terminal translation. Paste an error message or confusing output and ask Claude to explain it. Ask it to find the command you need for a specific task. Use it as an intelligent manual that answers in plain English. Summary. Claude Code is installed, your API key is connected, and your practice project folder is ready. The engine is running. In the next chapter, we give Claude a persistent memory of who you are, how you work, and what your projects look like, and that changes the quality of every session from this point forward. Chapter 2, Claude MD, the memory system that changes everything. Let me describe using Claude Code before and after a well-written Claude.md, because the difference is stark enough that it is worth a moment. Before, Claude writes JavaScript when your project is TypeScript. You correct it. It writes default exports when you use named exports. You correct it. It puts business logic in route handlers when you keep it in service files. You correct it. By the time the task is done, a significant portion of your interaction has been correction rather than creation. After, Claude already knows it is TypeScript, named exports, service files for business logic, the git commit format, the test framework, the database conventions. The session starts already calibrated. You spend your time on the actual problem. None of the knowledge in the after scenario came from reading your code files. It came from reading CLAUDDD. That is the power of this system. You write the rules once, and they apply to every session in that project, forever, without being asked. Layer 1 is the global file, your personal working style that applies across every project on your machine. Layer 2 is the project file at the root of each repo, everything Claude needs to know about this specific codebase. Layer 3 is subfolder files, narrowly scoped rules that activate only when Claude is working in that specific directory. Perfect for security-sensitive modules, unusual patterns, or areas where generic rules need overriding. STE. The global file lives at C users, your name, docta, seat users, your name, docta MD. This applies to every Claude code session on your machine. The project file lives at C users, your name projects, my Claude project CLAUDDD, not MD. This applies only in sessions launched from this project folder. Subfolder files live at any level inside the project. For example, C users your name projects my Claude project RCRSMED. This activates automatically when Claude works on files in that folder. In Windows Terminal, type cd-pru serprofile pret Claude and press Enter. If you get an error saying the folder does not exist, type mcdir terprofile prefilfile bpnd Claude, press Enter. Then repeat the cd command. Now type notepadquad.md and press Enter. A dialog asks if you want to create a new file. Click Yes. Notepad opens with a blank document. Come back to the text for this one. Copy the global template below, paste it into Notepad, fill in your name and role, save with Ctrl+S, close Notepad. In Windows Terminal, type cd profile erprofile projects, my Claude projects, and press Enter. This demonstrates module-specific rules that only activate when Claude works in that folder. We use auth because security-specific rules are a perfect fit for this pattern. Type mkdir src and press Enter. Skip if src already exists. Type mkdir cauth and press Enter. Type notepad srkuddmd and press Enter. Click Yes. Make sure you are in the project root, cd pru e cd serprofile projects, projects my Claude project. Once Claude code starts, type summarize everything you know about me, this project, and any special rules for specific modules. Press Enter. Claude should draw from all three layers. Look for your name from the global file, the tech stack and folder conventions from the project file, and the auth security rules from the subfolder file. If all three appear, the memory system is working across all layers. Treat these files as living documents. The most effective Claude.md files are ones that grow with the project. Every time you catch yourself correcting Claude on something, add a rule for it. Every architectural decision your team makes, write it down. Every time a library is upgraded or a pattern changes, update the file. Keep them concise. If your project, callad.md, grows past 800 words, you are consuming too much context on documentation rather than leaving room for code. Prune aggressively. If a rule is being followed consistently and Claude never violates it, it might not need to be in the file anymore. Use headings and bullet points throughout. Claude reads Markdown structure and uses the hierarchy to understand which rules apply to which situations. Claude MD sits directly under the agent in the master architecture mind map. It is what shapes every output the agent produces. When an MCP server returns live database data in Chapter 3, Claude applies your CLAUDDD.md conventions to decide how to use it. When a hook fires in Chapter 4, the output comes shaped by your CLAUDDD rules. When a skill runs in Chapter 5, it follows the patterns you defined here. When a subagent is spawned in Chapter 6, it inherits your project CLAUD.MD automatically. This is the multiplier layer. Invest time in writing it well, and every other chapter delivers better results with no extra effort. 1. Joining a new team. Read the team's docs and existing code on day 1, then write a project CLAUD, not MD, capturing their actual conventions. Claude codes in their style, their naming, their structure, their patterns, without you explaining it every time. 2. Multi-client freelancing. You work with 3 clients who all have different stacks. Each gets its own project, CLAU.MD. When you switch client folders, Claude instantly adapts. No context overhead, no explaining the stack from scratch each session. 3. Security enforcement without babysitting. The auth subfolder CLUD.MD means every time Claude touches authentication code, the security rules are active. You do not have to remember to say use bcrypt with 12 rounds. The file says it every session. Summary. You now have a 3-layer memory system. Claude knows who you are, your project's structure, and the rules that apply to the specific area it is working in before every session automatically. The amnesia problem is solved. In the next chapter, we connect Claude to the outside world. Chapter 3, MCP Servers, Connecting Claude to the Outside World. Think about how a senior developer actually works when solving a hard problem. They do not just look at local files. They query the database to understand what the real data looks like. They check the pull request that went in last week to understand a behavior change. They search the documentation to confirm an API signature has not shifted. They look at the error log to see the actual stack trace, not a description of one. Without MCP, Claude Code can do none of that. It is limited to local files and terminal commands. It cannot see your database. It cannot reach GitHub. It cannot search the web. It works in isolation from every tool in your actual workflow. MCP, Model Context Protocol, closes that gap. Each MCP server is a lightweight program that runs alongside Claude Code and gives it a new category of tool. Install the GitHub server, and Claude can read your repositories, pull requests, and issues. Install the Postgres server, and Claude can query your database directly. Install Perplexity, and Claude can search the live internet. You configure which servers are active in a settings.json file. Claude reads it at startup and connects to each one. From that point, using those tools is completely natural. You ask Claude for what you need in plain English, and it calls the right server. Over 400 MCP servers exist today. After this chapter, we will have 2 installed, a solid foundation, and you will understand exactly how to add more. Steps. NMBP server configuration lives in the global settings.json at C. Users Seviers m.json. In Windows Terminal, type cd profile profiled and press Enter. Type notepad settings.json and press Enter. If the file does not exist yet, click Yes to create it. If the file is empty, come back to the text for this one and paste in this structure before adding any servers. Deleted. Go look at original. Hello. Perplexity gives Claude real-time web search. When Claude does not know the current version of a library, or you want it to verify current documentation before making a change, it queries Perplexity and reads the live results. Open Edge. Go to perplexity.ai, sign up or log in. Click your profile picture top right. Find the API section. Generate a new API key. Copy it. Paste it into a temporary notepad. Deleted, go look at original. Hello, replace your key. Here with your actual key. Keep the quotation marks. Save with Control S. Open Edge. Go to github.com. Log in. Click your profile picture top right. Click Settings. Scroll all the way down the left sidebar. Click Developer Settings. Click Personal Access Tokens. Click Tokens Classic. Click Generate New Token. Choose Generate New Token Classic. Name it Claude Code. Set expiration to 90 days. Check these boxes: Repo, Read, Org, Read, User. Click Generate Token at the bottom. Copy it immediately. It is shown once. Paste it into your notepad. Come back to the text. Add the GitHub block after the Perplexity block. Note the comma after Perplexity's closing brace. That comma is required in JSON to separate two entries. Invalid JSON causes Claude Code to fail silently on startup. Before testing, validate the file. Come back to the text for this command. Copy and paste it into Windows Terminal. If the output is JSON is valid, you are good to go. If you see a parse error, look for a missing comma between server blocks, a mismatched quotation mark, or a trailing comma after the last entry, not allowed in JSON. Navigate to your project. CD print US ERPROFILE PROVEX projects. My Claude project type Claude and press enter. Once Claude starts, type MCP and press enter. You should see Perplexity and GitHub listed as connected. Try a live query. Type, search the web for the current LTS version of Node.js and tell me whether the version in our Claude.md is still current. Claude calls Perplexity, reads the results, compares against your project's clau.md, and gives you a live answer. One prompt. No browser, no tab switching. You now have two servers. Here are the most impactful ones to add next depending on your workflow. PostgreSQL. Let's Claude query your live database directly. Package, Model Context Protocol Server. Postgres provide your connection string in the NV block. File system. Access files outside the project folder. Package. Model Context Protocol Server. File system. Specify which folders it is allowed to read. Jira or Linear. Read and create tickets. Claude can pick up the next ticket and implement it. In the master architecture mind map, MCP is the right branch. Connections to the outside world. They are most powerful when Claude.md is already in place, because Claude uses your project context to decide what to do with retrieved data. The GitHub MCP gives Claude access to your repos. See all your branch naming, convention, and PR process. One without the other is less useful. Together, they are significantly more capable. In later chapters, MCP servers are also what power specialist subagents. A database subagent in Chapter 6 is only useful if it has access to the Postgres MCP. The connections you set up here underpin everything that follows. 1. Debugging a production data issue. With the Postgres MCP connected to your staging database, say, query the users table for records created in the last 24 hours where email verified is false, and check whether the verification emails were queued. Claude runs the query, reads the results, and forms a hypothesis. You wrote no SQL. You opened no database client. 2. Code review with live context. With GitHub connected, before opening a PR, say, read the last 5 commits to main and tell me whether my branch has conflicts or overlaps with changes that went in this week. Claude reads the actual commits. 3. Library research in context. Integrating a new library, say, search for the current API for Zod's transform method, then update the validation schemas in sargroutes to use the current syntax. Claude researches and applies the change in one step. Summary. Claude can now reach beyond your machine. GitHub, live web search, and anything else you add to settings.json becomes available through plain English requests. In the next chapter, we add the safety layer, the hooks that make autonomous use of these capabilities reliable and safe. Chapter 4. Hooks Rules. Claude cannot break. There is a spectrum of trust when running an AI agent on real work. Fully trust it and let it do anything, risky. Approve every single action manually, pointless overhead. Hooks are how you find the right position on that spectrum. The key distinction between Claude.md and hooks is this. Claude.md gives Claude guidelines. It reads and tries to follow. Hooks are scripts that Claude code runs deterministically, regardless of what Claude decided. Claude does not decide whether the hook runs. Claude code runs it for every matching action every time. If a hook script exits with code 2, the action is blocked. Not discouraged, blocked. The command never executes. The file is never written. The commit never happens. This is the difference between a guideline and a law. Pre-tool use fires before any tool call. You inspect the pending action and can cancel it before it runs. This is where you block dangerous commands. Post-tool use fires after a tool call. You react to what Claude just did. This is where you auto-lint every file Claude writes. Notification fires when Claude wants to send you a message, useful for filtering or routing important alerts. Stop fires when Claude declares a task complete. This is where Windows desktop notifications go, so you can step away from the machine and come back when you are paged. steps. The post-tool use hook we are building calls ESLint. We need it installed in the project before the hook will work. Open a second Windows Terminal tab by pressing Ctrl, Shift, and T. Navigate to your project. CD pressed 8U Serpro file. Projects my Claude. Project. Initialize a package. .json if one does not exist. npm init-y. Install ESLint. npm install, save dev ESLint hooks, live in your project's .claude folder. In the main terminal, cd present user profile projects, my Claude project, mcatedeer, r.claude type, notepad, Claude settings.json and press enter. Click yes to create the file. Come back to the text for this one. This is the complete hooks configuration. Copy the entire block and paste it into Notepad. The pre-tool use hook watches for any bash tool call. When Claude is about to run a terminal command, this hook first inspects the command string. If it finds any of these patterns, rm, rff, del s, sq, format C, drop database, drop table, or truncate table, it prints hook blocked and exits with code 2. Exit code 2 tells Claude code to abort the action entirely and report what was blocked. The command never runs. The post-tool use hook fires every time Claude uses write, edit, or multi-edit, anytime it writes to a file. It runs ESLint with the tfix flag on the file that was just written. The exit 0 at the end means ESLint warnings do not block Claude's work. The to null suppresses error output so it does not pollute your session. Every file Claude touches is automatically linted and fixed. The stop hook fires when Claude declares a task finished. It uses PowerShell to show a Windows balloon notification in the bottom right corner of your screen. This is how you step away from the machine during a long agentic session and get paged when work is done. Navigate to your project and launch Claude, cd pro, se, or profile. Projects, my Claude. Projects, my Claude. Project, Claude. Test the notification hook first. Ask Claude to do something small. Write a function called greet that takes a name string and returns a hello message. Save it to sark koodles greet.ts. When Claude finishes, wait a few seconds. A balloon notification should appear in the bottom right corner of your screen. If the notification does not show, press Windows key and I to open Settings. Go to System, then Notifications. Make sure notifications are turned on. Test the safety hook. Type, please run the terminal command rmrfhe to demonstrate the block. You should see Claude code report the command was blocked by a hook with the hook blocked message. The command was never executed. In the master architecture, hooks wrap around the codebase layer. They apply to every action Claude takes, including actions triggered by MCP calls, by skills, and by subagents. A subagent that writes files will have those files auto-linted. A subagent that runs bash commands will be blocked if it tries something on the danger list. Hooks apply universally. This is why we build them before skills and subagents. Everything that comes after is already covered. 1. Safe overnight runs. Set Claude working on a large refactor before you sleep. Danger block hook prevents catastrophic commands. Lint hook keeps code clean. Stop hook sends a notification. Swap the PowerShell balloon for a Slack webhook if you want it on your phone when it finishes. Wake up to completed work. 2. Pre-push secret scanning. A pre-tool use hook that fires before any git push command. It scans staged files for patterns matching common API key formats. If found, the push is blocked and the file name is reported. Secrets never reach the remote. 3. Auto test on every write. Change post tool use to run the matching test file every time Claude writes a source file. If Claude writes circ services alf.service.ts, the hook runs srservice.ts automatically. Test results update in real time as Claude codes. Summary. Your safety rails are in place. Dangerous commands are blocked before they execute. Every file Claude writes is automatically linted. Desktop notifications tell you when long tasks finish. In the next chapter, we build reusable workflows, skills that Claude follows precisely on demand. Chapter 5. Skills, reusable workflows as /commands. Here is a pattern every developer who uses AI tools seriously runs into. There are 5 or 6 types of request that produce much better results with a specific setup prompt. 30 words of actual request, followed by 100 words of instructions. Claude needs to do it well. So you either paste those instructions every time, which is friction, or you accept worse output without them, which defeats the purpose. A skill is a markdown file defining a complete workflow, the steps to follow, what to check, how to format the output. You write it once. You invoke it with a / command. Claude reads and follows it precisely every time, with no forgetting the format halfway through, no skipping the edge case check, no guessing at the output structure. Skills also have an auto-activation mechanism. Each has a description field, Claude reads. When you ask for something matching a skill's description, Claude can load and apply it automatically, without you typing the / command. The skill becomes part of Claude's natural response behavior. Step Sinja. Skills can be global, all projects, or project-specific. We create both. Type notepad.claude skills code review.md and press enter. Click Yes. Come back to the text for this one. Type notepad.claude skills debug.md and press enter. Click Yes. Come back to the text. Type notepad.claude skills gitcommit.md and press enter. Click Yes. Come back to the text. Navigate to your project and launch Claude CD Profile Surprofile Projects My Claude Project Claude Type Code Review. Review sr/sketchdilsagreet.ts. Watch Claude follow the systematic protocol. Compare this step to what a plain review this file request produces. The difference is significant. The skill is doing that work. Skills sit inside the code-base layer of the master architecture mind map. Because Claude.md is already in place, every skill runs with your project's conventions as context automatically. Because hooks are in place, every file a skill writes is automatically linted. Because MCP is connected, a research-oriented skill can pull live data mid-workflow. The layers compound. Each skill is better because of the 3 layers beneath it. 1. Onboarding consistency. Share your eCloud skills folder with every new developer on the team. They instantly have your code review standards, debugging protocol, and commit conventions as /commands. The skills are the training. 2. PR quality gate. Make it a personal rule that every PR goes through code review before it is opened. Systematic, consistent, does not depend on you remembering the checklist in the moment. 3. Domain-specific workflows. Build skills for your area. Data engineers. A pipeline check that validates transformation logic and verifies idempotency. Embedded systems engineers. a memory review that checks stack usage, heap allocation, and pointer safety. The skill system is entirely domain agnostic. Summary: you now have reusable, precise workflows available as /commands. No more re explaining your process. No more inconsistent reviews. No more hoping Claude remembers the output format from last time. In the next chapter, we give Claude the ability to run multiple specialist workers simultaneously. Chapter 6: Subagents. Parallel Specialist AI Workers. Every AI model has a context window, the limit to how much it can hold in working memory at once. For Claude, that limit is around 200,000 tokens, which sounds large, but on real complex tasks it fills faster than you expect. Large files, long conversations, MCP responses, shell outputs, context gets consumed. When it fills, quality drops. Claude loses track of earlier decisions and starts making inconsistent choices. Subagents solve this directly. A subagent is a completely separate Claude worker with its own clean, isolated context window. The main agent, the one you are talking to, acts as an orchestrator. When a task is large or specialized enough, the main agent spawns a subagent, gives it a focused task, and waits for results. The subagent works in its own context with no interference from the main conversation. And beyond context management, a subagent dedicated entirely to PostgreSQL schema design will write better migrations than a generalist simultaneously thinking about React components and test coverage. Specialist focus produces specialist quality. Each subagent has 3 configurable properties: its system prompt, which defines its identity and rules; its tool access, which limits exactly what it can do; and optionally its MCP server access, which determines what external data it can reach. Steps: TA, navigate to your project, CD per usurper file, projects my Claude, project, type, mkdir I Claude agents, and press enter. Type notepad.claudeagentsdbexpert.md and press enter. Click yes. Come back to the text. Type notepad.claudeagentstestwriter.md and press enter. Click yes. Come back to the text. Type notepad.claudeagentsecurityauditor.md and press enter. Click yes. Come back to the text. Launch Claude Code CD Profile Projects My Claude Projects My Claude Project Claude. Invoke the DB Expert explicitly. Type use the DB Expert subagent to design a notifications table with fields: ID, user id, type, title, body, read at, created at watchit, spawn with its own context, work through the schema, and return structured output in the exact format its definition specifies: migration, SQL, rollback SQL, and indexes. Then invoke the security auditor. Use the security auditor to review sqrtilsgreet.ts and report any security concerns in the standard format. The auditor reads the file and returns a severity-ranked report. In the master architecture mind map, subagents are the rightmost branch, parallel workers. They inherit the project claud.md by default. They are constrained by the same hooks that apply to the main agent. They can be given specific MCP server access. The DB expert can have Postgres MCP, and the security auditor explicitly does not. Every layer you have already built makes each subagent more capable and its outputs more reliable. 1. Parallel feature build, spawn DB expert for schema, test writer for coverage, security, auditor for review. All 3 work simultaneously. A full feature in one parallel session. 2. Context management on large refactors. When a codebase change is too large for one context window, split it across subagents. Each works on their section in isolation. Main agent tracks progress and synthesizes. The task scales beyond one window. 3. Continuous security practice. Before any PR, spawn the security auditor on the changed files. It costs nothing extra once it is defined, and it is more consistent than a manual security review done from memory. Summary. You now have 3 pre-configured specialist workers ready for any task. In the final chapter, we bring everything together with agent teams, composing these specialists dynamically for any task at any scale from a single prompt. Chapter 7. Agent teams orchestrate the whole stack from one prompt. Everything built so far, the 3-layer memory, the live connections, the safety hooks, the workflow, skills, the specialist subagents, each piece valuable on its own. Agent teams are where they all compound into something that changes what one developer can accomplish in a single session. Here is the core idea. Subagents are standing team members with pre-written job descriptions invoked by name. Agent teams are task forces composed on the fly. Instead of knowing in advance which specialists you need, you describe the task, and the lead agent works out the composition, the delegation, and the sequencing. For teams you use frequently, you save the composition in a teams.json file, your standard feature squad, your audit team, your documentation sprint crew, and reference them by name. Let me make the impact concrete. A feature that typically takes a solo developer a full day: database schema, API routes, test coverage, security review can be completed in one Claude Code session with the right agent team. The agents work in parallel. Each stays in their lane with focused context, and the lead agent synthesizes everything into one coherent, reviewed, tested, and audited result. This is not magic. It is coordination. The same coordination a technical lead provides when delegating to a team. Claude Code handles the coordination. You provide the requirements. Steps. No configuration file needed. The entire composition comes from your prompt. Navigate to your project and launch Claude CD Press UE Serpro file projects. My Claude project, Claude Press. Enter and let the team work. This takes several minutes. Watch Claude track the agents, report on progress, and synthesize. The final summary is your implementation brief. Review it carefully. Type notepad.claude.teams.json and press enter. Click Yes. Come back to the text for this template. Launch Claude Code. Claude invoke the team by name with a 1-sentence feature description. Using the Feature Squad team, implement a user preferences endpoint that lets users store notification settings. Claude reads the team definition, sets up the composition, and runs it. You describe the feature in 1 sentence. The team handled the rest. For smaller tasks, use the Quick Build team. Using the Quick Build team, add an endpoint to mark all notifications as read for the current user. When writing your own dynamic team prompts, this structure produces the most reliable results. Come back to the text for this template. Precision in scope descriptions matters. Build the backend is too vague. Implement 3 express endpoints following CLA-U.MD conventions is specific enough for Claude to delegate effectively. This is the top of the master architecture mind map. Agent teams are the highest leverage feature in Claude Code, but they are only as good as the foundation beneath them. A team running on a strong CLAUD.MD with live MCP data access, with hook safety rails, with skill workflows for consistent subtasks, and with well-defined sub-agent specialists is dramatically more capable than a team running on none of that. The 7 chapters compound. This is why this is the final chapter and not the first. When you look at the master mind map now, after having built all 7 layers, what you see is not 7 separate features. It is one coherent system where each layer amplifies the ones around it. 1. Complete feature in one session: database agent, backend agent, test agent, and security agent all working in parallel on a feature that would otherwise take a solo developer a full day. 1 session. 1 clean summary at the end. 2. Legacy codebase audit. Assemble a reading agent that maps the architecture, a debt agent that identifies the worst technical debt, and a security agent that scans for vulnerabilities. All in parallel. Get a full audit report in 1 session. 3. Documentation sprint. 1 agent reads every file in the codebase, Another writes JSDoc for every undocumented exported function. A third writes a README that reflects what the code actually does. Documentation done in hours instead of weeks. Summary. You can now compose specialist AI teams from a single prompt. Static teams saved in teams.json referenced by name. Dynamic teams described on the fly. Every team inherits your Claude.md, is constrained by your hooks, can reach your MCP connections, and can invoke your skills. The whole setup compounds with every session you use it. You now have a 3-layer memory system, live connections to GitHub and web search, deterministic safety hooks, 3 reusable skill workflows, 3 specialist subagents, and the ability to compose full AI teams from a single prompt. Most developers using Claude Code have perhaps 1 or 2 of those things. You have all 7 built in the right order, each one amplifying the others. 3 practices make the difference between a setup that stays static and one that compounds over time. First, every time you catch yourself correcting Claude, add the correction to claud.md. That correction is a rule waiting to be written. Write it, and Claude stops making that mistake in every future session. Second, every time you type the same long instructions twice, turn them into a skill. That is the threshold, 2 times. If you have written the same setup prompt more than once, it belongs in d.claude.skills, she as a / command. Third, visit the MCP server directory every couple of months. The community keeps publishing new servers. When one lands that fits your workflow, 5 minutes of setup unlocks an entire new category of Claude capability. The developers getting the most out of Claude Code treat the configuration as a product worth maintaining, not a one-time setup that sits unchanged. Invest 15 minutes every week into improving your Claude.md, refining a skill, or adding a new MCP connection. The compound effect over 3 months is significant.